Welcome to today's Coffee Talk. My name is Frank Crawford. I am the Education Committee Lead for Passive House Alberta. Today's talk is from David Campbell and Ryan Young of T5M Connect, and they will be discussing the use of Passive House Standard for the multifamily rental project building they are constructing in Edmonton. This coffee talk is open to the public, but please, if possible, take a look at some of the Passive House Alberta membership options. They're $25 per year for students and $40 per year for individuals, as those membership fees go a long way and are critical to us being able to continue our programming and work such as these coffee talks. And the coffee talks will shortly be returning to a member-only event. However, the next coffee talk, which will be on the 4th Tuesday of January, will also be open to the public, and it will be on cold climate heat pumps with Derek Chamberlain, who is the Prairie Region Sales Manager for Daikin Canada. And then our February coffee talk will be with Alex Degagnier, who is the Vice President of Sales and Marketing and the co-owner of Minutair Inc. And they are a manufacturer of all-in-one heating, ventilation, air conditioning, and dehumidification units that are manufactured in Quebec. Please type in any questions you have for the speakers in the chat box, and we'll go over them at the end. And now I'll briefly introduce today's speakers. David Campbell has a background in development, project management, and construction of large and small scale multifamily and residential construction projects. He has worked on 2 of Edmonton's largest adaptive reuse projects. He is currently working on 3 missing middle infill projects, including the TM5 Connect project that we'll hear about today. Ryan Young has a background in finance and managing organizations. He is currently the Associate Dean, Industry Engagement of the J.R. Shaw School of Business. Before that, he started and managed a large international finance agency, and he's been active in the energy-related organizations in Alberta and is a fan of community-minded infill projects that make Edmonton a leader in environmental sustainability. Ryan holds an MBA from the University of Alberta and is currently completing his doctorate in entrepreneurship. So take it away, Ryan and David.
Hey, thanks very much for this opportunity. We're very excited to be speaking today and for having a chat with you. Just before we get going, I'd like to introduce our team that are on this call. So you've heard from about myself and David, and I see that Oscar Fletchis is on the call, and I saw Kelly Fortis is on the call as well. And I'm not sure if anyone else from our team is here. Michelle and Melissa are on the call as well, I believe. So it'll be a good number of us here. So at the end, when we have some questions, might be able to get a little bit more specific and get more detailed questions if people want to take it deeper. So yeah, so thanks for this presentation. We'll keep it roughly about half an hour, so there's plenty of time for conversations and questions after. So yeah, once again, we are a small group that has started a project in a development in a community in Edmonton. There's the screens. And really our goal is, as it says on the screen, we want to attempt to do passive house standards in a missing middle context that makes both environmental and economic sense. And through this process, we want to demonstrate to the community that it is possible to do and inspire others to try to do the same. So that's really our overall goal. But as we're going ahead, there was 3 sub-goals which we tried to achieve throughout this. The first one is to determine what is the marginal cost of doing a passive house build. You know, when specifically looking at the mechanical envelope and solar PV. So that's something that David's going to walk through later on this presentation on how we answer that question. The second one is looking at the 2 different passive house standards that are out there. You know, we got FIAS and we've got PHI, and there's many. When we were starting off, quite frequently people said, well, which one are you following? So we explored both, and we're going to walk you through the steps on how we came to our decision on which one we decided to use. And the third goal that we wanted to achieve was to determine a net zero strategy. You know, is it possible to reach net zero in our development with passive house? And if not, how close can we get? So those are the 3 goals. And throughout the presentation, we'll be answering these three questions. So once again, our design team, which we introduced a few on the call. So I believe almost everyone is here today, so you'll be able to get a great presentation and great answers, detailed questions if you have them from any of our teammates, if they're willing to jump on the call at the end and ask. But yeah, so this is put together largely David Campbell. I attribute lots to him for assembling this team and for leading us through that. So yeah, so great. There's our team, and we'll move on forward. So quick introduction to our project. We are in the community, a 1950s mature neighborhood in Edmonton. So for you, it's North Glenora if you're from Edmonton. And if you're from Calgary, it is probably similar to something like Glendale or Glamorgan, that kind of area where there's, it's 1950s, there's starting to be some turnover in renewal, but there's still, the homes are starting to get dated. The best of my knowledge, that's what those communities are like. So yeah, what we have here is we have two city lots that are adjacent to each other that are right across from a school in the middle of a neighborhood. Yeah, so you can see an overview of what it is. It's basically a typical 1950 style bungalow. And it's approximately, I believe, well, here's the other pictures of them here, 2 single family homes. Total area is 13,500 square foot. And yeah, 2 homes side by side adjacent to one another that we're doing this project on. So we just tore down these homes this past week. So now it's just two empty lots, and we're ready to get going on here. And our vision is to develop multifamily build, 16 homes that are mixed with 1, 2, and 3 bedroom units. They're, as you can see, about 2.5 stories tall, and 2 of the units are going to be fully accessible. And yeah, really catering to the community in a sense. We want to attract make it accessible and appealing to different segments of society. So we're not targeting one particular group in general. We are trying to say that this can be anywhere from university students to retirees to families as well too. So we want to make it quite a diverse group of people who will be living in this when this is done. And here's some renderings of the project so you can kind of get a sense of what they're like. So it's 2 buildings that are adjacent to one another that form, if you look in the bottom left-hand corner, they kind of form like a U shape if you look at it, where there's an inner courtyard where a lot of the homes face into in the middle section here. And then the top left corner is the view from the school. So if you're standing across the street at the school, that's the view that you would have. The top right corner is the view that you would have from the avenue. So if you're just south of the building looking forward. So as you can see from that one, that the building is not the same height all the way across. We've lowered the west side of the buildings, the units on the left side, for a variety of reasons. And particularly one of the reasons was just because the neighbor to the north has a beautiful garden and was really concerned about her garden. So we tried to lower it to maximize the sunlight that would go into her garden space. The bottom right-hand corner is the inner courtyard where the units would flow into. So all of the units are pretty much facing southward, and this would be what we're looking at is the north building facing southward. So that's the inner courtyard that they would have. David, I don't know if you have any more comments that you want to add to this particular picture to highlight before we move on to the.
No, I don't think so.
Okay. I'm trying to go fairly quickly just so that you can, so we can get to some of the technical stuff, because I was told that a lot of people on this call might want to know the technicalities of this. So, yeah, so I think I'm passing this off to David now. Am I not? David, is this where we start with you?
Well, I was going to start on the wall systems, but I can start here.
Okay, sure.
So basically, we wanted to define the marginal cost. In order to do that, we had to determine what we were going to build exactly. And the methodology we used was we kind of came up with the base Alberta Building Code scenario, and then we compared everything back against that so that we could get the difference between our proposed systems and the minimum code cost. We started by defining the building envelope and choosing that, and then layering on top of that mechanical, electrical, and solar options for each system. And then Thomas from Alterna, now with Niche, did a great job for us analyzing, not just the installation costs, but also the operation maintenance costs and like full life cycle costs for each of the systems, so that we could make a decision for implementation, not just on the initial cost, but on the cost over the whole project. So for wall systems, the way it kind of worked was we brainstormed some ideas, me and Oscar, for the most part, of different ways that we could build the wall system for a high performance building. And then Kelly took each of the proposed systems, because she's the energy modeler and mechanical engineer, and kind of took a dive into them and defined exactly what we would need to meet each of the standards. So we have a bunch of different wall systems we analyzed, both FIAS wall types and to meet PHI. So I'll just walk through them super quick. Envelope 1, we just looked at the basic building code scenario. So basically 2x6 walls with bad insulation. Envelope 2, we looked at using a double stud system to meet the FIAS standards. So this ended up being 12.5 inches thick. I don't know, I don't want to go into all the detail, but we're using ICF and we have 8 inches of EPS below the slab. Envelope 2B is with the exterior, the insulation on the exterior. It meets the same FIAS standard, but all we've done is instead of using double stud wall, we've moved the exterior insulation. Next, please. 2C, we looked at this really innovative building system out of the UK. They were at least discussing starting a plant in Edmonton at the time. It's similar to a structural insulated panel. I don't want to go into it too much in detail because it quickly got eliminated because it was really expensive. Envelope 2D that we looked at was the SI wall system. So I don't think Mark Cunningham from SI Wall Systems is here, but this is a system mixed of like gauge steel stud and like embedded in EPS. So this required R41. It met the FIAS standard. And the basement, they have a system where you're using the same system rather than a cast in place concrete wall system. Envelope 2E, we looked at the FIAS prescriptive. So this is just a program from FIAS that says if you build to this certain standard, you don't need to do all the in-depth energy modeling and thermal bridge analysis. We've already done it. We know what it is. Just build to this standard and you'd be able to get certified as FIAS. It's not much different than the double stud wall, but it actually is a little bit higher level. Right, next. Okay, so 2F is almost the same as 2D, but we're combining the upper, like the SI wall system, this like gauge steel in EPS with more traditional ICF foundation. And the reason we explored that was just to have an option where we had a concrete foundation rather than a like gauge steel and styrofoam, which would be like, I guess, considered outside the norm. Then we looked at a bunch of wall systems that met the PHI standard. So envelope 3A is a double stud wall. It's very similar to the double stud wall we looked at for FIAS, but to meet the PHI standard, it needs to be thicker, R60. In this scenario, we have a little bit more EPS in the basement, and there's a little bit more below the slab, and the roof is a little bit thicker. Just to meet the PHI standard, which is in our climate higher than the FIAS standard. 3B is the same as earlier with the FIAS standard, except for we have more outboard insulation to meet the higher standard. Next. And then this is 3C. This is that the mantle system I talked about earlier, but now beefed up a little bit to meet PHI rather than FIAS. All right, so we did a huge analysis, which we took out of the presentation because it's way too hard to see and way too big, but basically took costs for everything like framing, insulation, for each component like roof, walls, basement slab, analyzed it all together and totally costed out the building envelope. And we did this when we were getting started on our design development. So it's a bit old now. It's almost a year old because this was the basis of our decision making. And then once we made our decision, we've been continuing to move forward without circling back. At the end, I'll go back and I'll update this with the actual cost of what we spent. And it's going to be interesting to look back at because prices have changed quite a bit. Like lumber was expensive when we did this. Since then it's dropped and the price of steel and EPS has continued to go up. So if I did this analysis again right now, I bet you it would be a little bit different. But you can see by looking at this, all the each of the wall systems and their costs. And this is marginal costs over the Alberta building code scenario on the left, which would cost nothing. You kind of start to see the cost effects. You can see the mantle systems that were just so much higher than the rest that we eliminated that right away. And then you can see, actually, let's go to the next slide, Ryan. This is the percentage increase of total construction costs associated to the envelope. So this is how much extra the envelope costs over the Alberta building code. With the 3 on the right being the PHI options, and then the 5, 6 on the left being the FIAS options. Next. Okay, so that was the envelope. Then we started looking at mechanical systems, and I have to credit most of this work to Thomas, with also Kelly, who analyzed all these systems for us. But these are the systems we looked at. We looked at one, a traditional furnace on the main floor with electric baseboard in the basement, standard hot water tank, standard HRV, and AC on the main floor. And then mechanical 1B is the same, but without the AC. We knew we weren't going to do these systems right from the beginning, but we wanted to analyze them so that it gave us a baseline to see what we're spending on extra, more high-speed equipment. Mechanical system number 2A, we looked at air source heat pump, upstairs and downstairs. Well, basements are like the lower units. So 8 of our units are partially below ground. You could think of it as a traditional like basement suite almost, but raised out of the ground more than a full basement. The difference between A and B is in A, each unit had its own outdoor condenser, and in 2B, they were shared like between the upper and the lower units. The system 3A was a ground source heat pump, electric baseboard heat in the basement, air source heat pump for the hot water as well. That was in 2A and 2B as well, and an ERV. And then system 4 is just electric baseboard heat throughout with the air source heat pump hot water tank and an ERV. Let's go to the next slide. So here, this slide shows a couple things. On the left-hand side, you can see the envelope installation cost conditionally formatting so that the cheapest ones are green and the most expensive ones are red. And then across the other columns is each of the heating, each of the HVAC options. They're actually formatted to change based on which envelope we chose. So in theory, what I hear a lot is like, passive house, you're going to spend money on the envelope and then you're going to save money on the heating and ventilation system. And we wanted to know if that was true. And what we actually found, or what Thomas found in the analysis, was that no matter what wall system we chose, the cost to install the heating and ventilation system didn't really change. And that was because there's not many choices of size for air source heat pumps, and we end up using the smallest size equipment no matter which wall type we use. If there had been options for smaller equipment, we might have been able to save some money. So one thing we wanted to consider was like, if we pay the extra money to do PHI envelope over FIAS, like could we save that money on the heating system? And what we found was that we couldn't. Next slide, Ryan. The slide's really great because it gives a real snapshot into the total installation costs and maintenance and operations for a year. So this is total marginal cost, or total cost of installing everything, including envelope, including mechanical system, and then conditionally formatted. So when you look at the 1 year period, you can see pretty quickly that the furnace's options on the left and the baseboard heating on the right are the cheapest. Yeah, I think let's go to the next slide. This is the same thing, but over 5 years, and you still see the same pattern with the green being in the furnaces and the electric baseboard, but it's getting less so. And next slide, Ryan. So this is over 25 years and things start to shift. Still, you see the electric baseboard heat on the right-hand side being the cheapest. So this savings in electrical costs, like for using the air source heat pumps, never make up for their initial installation costs. But you start to see some light green showing up around the middle of the screen, like under air source heat pump in the FIAS scenarios. Next screen. So this is a snapshot of some of the modeling that Kelly did. It shows indoor air temperatures during the summer months of some of the one of the lower units. So these are, if you think about our project, like this is really our basement suites. And from this picture, you can see how many days that the indoor air temperature is modeled to go past 25 degrees. Like it's a substantial amount through the months of June, July, and August. And no matter how much I pushed back on Kelly, that this couldn't possibly be right. And we definitely don't need AC in the basements. And can we mess with windows, and what else can we do? The answers always came back that this is right. And if we don't do anything with AC, then the units, even in the basements, are going to be uncomfortably hot. Next, Ryan. So this is just back to our 25-year snapshot of the life cycle costs, including installation. Next, Ryan. So we eliminated these two options, the furnace with no AC and electric baseboard heat only, based on the fact that without AC, the units will be unlivable. Next, we eliminated the air source heat pump with the centralized system because we want to individually meter each of the units, and having a system that was shared wouldn't allow us to properly meter the equipment. Next, Ryan. Then we focused in on these two wall systems because they had the lowest life cycle costs over 25 years. This is the SI wall system. Remember, that was like gauge steel embedded in the EPS foam, both upstairs and in the basements. And then the lower one is the SI wall system with the insulated concrete form combinations. So concrete in the basement and the SI system above. Next, Ryan. And then we eliminated the SI walls, the full SI wall system. This was just a personal choice. The cost difference between the two systems wasn't that significant, and I was more comfortable having a concrete foundation, and I thought potential future buyers or even lenders would be more comfortable having a concrete foundation, even though the SI wall system is fully engineered and perfectly fine to use for below ground as well. So that's the combination we came to, that we're going to use the FIAS modeling with the SI wall system and ICF. And I realized that we're talking at a PHI event, but this is the conclusion that we came to, and that we're going to use the mechanical system 2A, the air source heat pumps. You know, really, we were looking for a standard that we could start with to work towards a net zero or a high performance building. And being fairly new in the industry, both the FIAS and the PHI gave us like a baseline. We really wanted to have a standard like, okay, we have to do this, and then we can work on net zero afterwards. Yeah, and then connecting to the grid, this gave building this standard gave a 50% reduction in total carbon emissions over the Alberta Building Code scenario. All right, next, please. This is the solar PV system as it's currently designed. Left-hand side is the roofs. Right-hand side is, this is actually the west-facing wall. This is 80 kilowatt, but it's not finished yet. I really want to get us all the way to net zero. Like our whole team is like pretty determined that we put in enough time and effort, energy and funds to get this close. Like we really want to be able to take it all the way to net zero. This design doesn't get us all the way there. But if we could tighten up the space between the panels and get one more row in there, we would be all the way there. I just haven't found a solar company willing to work with me on that solution yet, but I'm pretty sure it can work with Kubi some more, or work with somebody else, and we can get to that point. Next. Okay, so let's check in with our goals. So define the marginal cost of passive house. So this is what we came up with. The mechanical system was $139,000 extra. I must say we did this a year ago, and prices have changed significantly, especially in the world of heat pumps. So when we go and we refresh this, that mechanical cost is probably at least double that now. It's probably, yeah, at least 250,000 or more. The envelope additions cost 176,000. The solar PV was 226, and then the total was basically $550,000. It's about 12% cost premium. So actually, I had said earlier in the presentation that the envelope costs were about 12% higher, and then the entire project costs are actually 12% higher. So it's basically spread evenly between envelope and the rest of the project. Evaluate between FIAS and PHI. We selected FIAS, but actually on Oscar's recommendation, we're also exploring PHI low energy. I think we'll just do that at the end. And determine a net zero strategy. So we're not there yet. We can do, it works out to about 12 of the 16 units coming to net zero. But like I said, we're still trying to get all the way there. Next, Ryan. Things that we'd like to do that we didn't do right now is analyze the total embodied carbon. I think that's something we could do for the next project. It's something we thought about quite a bit, but at the time we made the decision, we didn't have a good idea on how to evaluate this. I think we've learned quite a bit since, and we could probably do it for the next time. Account for the carbon tax, which came into play partway through our analysis. And then the other thing we're working on is around like trying to prove that building to passive house makes sense, and has to do with, you know, showing how we can recover some of the extra costs that we put into the building. So looking at like, can you get a little bit extra rent because of the high environmental standards, or can you recover some utilities, or do you have less vacancy? Do you have a waiting list to rent the building? And evaluating that, because when we do our research, like we really find very little information about that.
Oh, there's one more thing too. The desirability, we still haven't done either. Is that what?
Yeah, I kind of muddled through both of them together, so I think that's good. And then I just wanted to point out that even though me and Ryan were speaking today, it's really been a big team effort, and a lot of learning for us and for me. So, you know, T5M Connect and Homestretch, that's us, and Oscar Fletches from Fletches Architecture, and Kelly from Renew doing the energy modeling and mechanical engineering, and Thomas doing mechanical design assist from Alterna. And I think most of us are here, and we could probably just turn it over to any questions that there are.
Great, thank you very much. So I got a few just clarification questions to start with. So I guess clarifying your goals, would be net zero energy using on-site renewable production as opposed to off-site credits?
Yeah, for sure. So one way or like, there's too many definitions of net zero. So one way or another, like it's definitely going to be totally powered by renewables, but we're really trying to do on-site net zero.
Excellent. And I'm assuming you're having no natural gas connection since you're using air source?
No, there's no natural gas.
Okay, so you'll be, so zero carbon emissions on site operationally, but you didn't track the embodied carbon yet because probably a few years ago it wasn't around, but going forward, it's easier to do. And I guess the other question, so that 12% marginal cost, that's just capital cost, or is that any life cycle on it with operation savings?
Capital cost. But if you were it's hard for me, I can't show my screen, but if you went to that 25-year life cycle analysis, you would actually see that over the 25 years that the FIAS or the options we chose for envelope and mechanical system are actually cheaper than using the furnace with the Alberta Building Code. So if you can take a long enough picture and maybe not account for the cost of capital over time, it's actually the cheapest option.
Yeah, and then I guess same thing. The solar panels are I guess passive house adjacent because that's for your net zero goal. So
yeah, right. Like we didn't need, we don't have to do any renewable energy purchasing or have solar to meet the passive house standards. But you know, when we did, you know, even if we meet the passive house standard with our chosen system, we're actually only dropping the carbon emissions by 50%.
Yeah.
So to us, it didn't make sense to do that and then not take the next step to go.
100%, especially the way that we can sell the. I assume you guys still qualify as microgen, or do you have to sign a larger agreement with an 80 kilowatt system?
Ryan knows way more about that than I do, so I'll leave that for him.
Yeah, we've had discussions, but we've not fully explored that yet, mainly because we haven't finalized the what the system is going to be on the roof yet. So, but we've had the discussions with used to be called Spark, but a couple other companies as well, just exploring what we can do.
Yeah, which they all use utility net in the background. So yeah, if you can stay within that microgen and be selling your summer overproduction at 26 cents, you're going to have no utility bills, which kind of eats away a lot of any capital costs. Like, I guess since it is rental, have you guys looked at making utilities fixed rent, like included in the rent, so that that's how you recover the costs?
Part of our dilemma, because with the rental in this system, like in townhome configuration, typically the tenants would pay the utilities. So we've invested upfront. There should be no utility bills. So like, how can we recover that? That's one thing we're exploring. We also used CMHC affordable housing, the near market rent program. So we reduced the rents by 10% below market. That caps our ability to raise rents to recapture some of these costs. So it kind of makes it a little bit more confusing. But
if you can still make if you can still make the financing work with all those constraints, why isn't everyone doing it? Because taking a few of those constraints out should make it much more easy to finance.
Well, the short version is like, this is far from profit maximizing. Like, you know what I mean? Like, this is a passion project for us and something we believe in and something we want to demonstrate. The short answer is like, we would make way more money if we just built a basic Alberta Building Code building and leased it out.
Yeah, someone's got to show how it can be done better, and then it's with all that amazing data you have, it's much easier to replicate it. I didn't see any other questions in the chat, but those online, you're more than welcome to type them in now, or just turn your camera or just mic on and ask away.
So we're building 12 units in 5 buildings down here in Medicine Hat. We started off with the concept of the double stud wall, but very quickly, in discussion with our framer, we went to single 2x6 and exterior insulation. So we have 2 systems, 4 inches of rock wool and veneer, and 4 inches of EPS and EFIS, the 2 sort of combination. But the one detail that we had to sort out on site, and I'm not sure we got the best detail, was the framing for the windows to bring them out to the exterior. So we ended up just sort of boxing them out and hanging the window sort of out in the air, 4 inches out on this boxed out plywood enclosure. Is there a better detail for that?
Hey, Oscar, can you take this question?
Okay.
There he is.
Good. How are you? Everyone, yeah, again, we also have the same idea here. We're gonna have the box windows. Typically, I prefer the details on how that doing any of the flange type of systems. It helps us just to position the window also on the perfect location. The benefit of using the SI system is that they can pre-mold the over insulation over the frame. So we simplify a lot of the detailing as well by doing just that system. If we were working on just the wood frame typical construction, it requires a little bit more of labor, to be honest. I've done it before, and still you can do it. And as I said, probably the benefit is that you know exactly where you're positioning that window on the opening. And I know that it's not that a common construction method sometimes, but once you explain to the framers and all that, they also find that it's a lot easier just to do it that way. And installation goes really fast. And one of my projects in Valley View, it probably took them kind of probably 2 hours just to install the first window. When I went there, I always joke because when I was for my inspection, I arrived at noon and they were able to demonstrate that they could install the full window in 8 minutes. So it's a little bit of learning on installation, but once you do it, it goes quite fast.
And I guess the one other thing to add is for windows, for both PHI and FIAS, the best place for a window is as close to the thermal center of the wall as you can. So you don't want it all the way to the outside. You want it somewhere near the middle of the wall, assuming you have insulation throughout. So even though the box out is the full depth of the wall, the window is kind of closer to the wall, so you're not that far from your 2x6 structure on the inside.
Thank you.
Kim had 1 or 2 questions. What energy modeling software was used to assess the project? And have you picked your actual air source heat pump, I guess, supplier or manufacturer at this point?
Kelly, can you answer these 2 questions?
Yeah, so in the preliminary analysis, we used IES. So in those scenarios that David was talking about, we were using IES for the energy modeling. And for load calculation for mechanical design, again, IES. And then for our passive house modeling, we're using the WFI FIAS energy modeling software. And I think that's all the different types. I have so many models. And then for the equipment that we selected, we've got Venmars for our ERVs, and we've got Daikin Sky Airs for our heat pumps. Any questions about those equipment or any other energy modeling?
Well, actually, no. Since you picked Daikin, if anyone wants to come back in January, we can ask Derek all the questions you want about the Sky Airs. But yeah, the Daikin products seem to be pretty good. I guess since you're using, another question just for me, since you're using the 3 different energy modeling softwares, can you briefly say maybe do they talk to each other all? Can like one export into the other one, or is it totally new data entry? And how is one of them quicker than the other, or do you see one being more accurate than the other? I guess any thoughts on that?
So they don't talk to each other at all. So even with like the geometry, like for the WFI passive, excuse me, we're using SketchUp to draw the geometry, whereas in IES, you draw right in it. Theoretically, you could use SketchUp with IES, but based on my experience, I found that it's more cumbersome and causes more trouble than it's worth. So I'd rather just draw it from scratch. I would say they're good for their different applications. Like IES, I would say, is more accurate with regards to like real life scenarios of what you're going to see with like consumption. So if you're looking at net zero energy modeling, I go more towards my IES software. And for load calculations, just for code purposes, we need to calculate that a certain way where we're not taking into consideration any internal gains from equipment, et cetera, or occupants. So that again is IES, whereas the WFI passive is, in my opinion, more specifically for getting to that standard target, just to see, are we meeting this standard or are we not meeting this standard? Yeah, that's primarily what I would say for that.
Thank you. Another question from Sean. Does the life cycle costs include all your borrowing and financing costs? Or is that on top of the increase as well?
Yeah, we've not really explored that fully yet. However, some things to keep in mind is, like, for example, as David said, we used a CMHC, and they provide a 10% discount on premiums for anyone who has, you know, a certain level of environmental standards. So once we cost it out, we'll do that at some point, but we haven't fully done that yet.
There's only $100,000 difference on the life cycle costs between like the very basic ABC building scenario with a furnace and the wall system we chose with the air source heat pumps, and it's quite capital intensive like at the beginning. So I would be afraid that if we actually did apply a cost of capital even at pretty low interest rates, that it wouldn't balance out. But it's a good question, and like Ryan said, like definitely something we need to go back to at the end.
If you do that as a part of the team, I can be a part of it, but we should definitely throw carbon tax in there. Especially if you're projecting over the next 20, 25 years. It's such a game changer, which I know that's like a bit of a shot in the dark based on what's happening politically, but it's worth checking out.
No, that's absolutely a good suggestion. And it's something, there's a student group at the University of Alberta looking at this project and trying to come up with some ideas for us about how to kind of recover some of this cost and show that, because we want to show it's financially viable, and not a whole ton of people are going to go build a better building if it costs them more money. And so one of the things we're looking at is, would you get a lower cap rate if you were to sell the project based on the high performance aspect of the building? And I think what Kelly said about the cap rate or about the carbon tax, like absolutely at some point people are going to catch on that it's going to be worth it. So we just have to figure a way to prove it out, I guess.
And I guess have you done a life cycle for say 50 to 100 years? Because hopefully these buildings are designed and built to last kind of forever. It is definitely a longer, I guess, time frame than most financiers look at. But if you're like some of the other larger builders do have that long of a life cycle that they look at.
Yeah, we did, and Thomas did most of the analysis for us, and he took it to 25 years. But I would think, my guess is honestly with the upfront costs and then, you know, anything that you're going to earn back after 25 years would be pretty not important. You know what I mean? But we could look at it longer.
I suspect that so Thomas picked 25 years based off of mechanical equipment life.
Oh, that's a good point.
Well, yeah, I suspect that was factored in there.
Yeah, and it's important to know that after probably the 20, I think that after the 10 years, there's still some maintenance, repair, or change on equipment that needs to happen. So it's kind of complicated when you think about it, even performance of equipment. What is that you're going to install 20 years from now? And all that. So there's a lot of scenarios really that we have to figure it out at some point to be sure that the right decision is made from day one. But at the same time, it's like, let's look at the 10, 25 years time frame. And if we incorporate, as Kelly's saying, I think it's $170 per carbon tax that I don't know kicks pretty soon. That is, I've done some modeling on other project, and it's like that's pretty quickly that you just recoup that money.
Yeah, it's almost like it's doing what it's exactly intended to do.
Yeah, like I remember discussing that loosely at when it first came in, and the information that I had got from Thomas was like a PV system saves as much money as it costs if you finance it over 10 years in carbon tax without even taking into account the savings of the electricity that it actually generates.
So since you have gone with the air source heat pumps, which gives you the heating and the cooling, Did you redo that graph on the interior temperatures? And I'm assuming they always stay in the comfortable 21, 22, or whatever they set the thermostat at?
Yes, yeah.
Yeah,
We
so-
do most of our net zero energy modeling, and just like our annual energy consumption modeling would be based off of an interior temperature of 21 for heating season and 25 for cooling season. So it's a bit higher than some may find comfortable. Personally, I'd be okay because I don't even have air conditioning at the moment. So 25 would be a luxury, but
yeah, so there is definitely the comfort increase bring.
Mhm.
And if there's a heat dome or anything else, doesn't matter what the outside temperature is, you will be comfortable inside your passive house.
Mhm.
Yeah, and I bet that that's why we're using more and more the air source heat pump. That again, we technically get a little bit of that free cooling in the summer by having just that type of equipment that we couldn't do with some other type of mechanical systems. And I think that's kind of the selling points right now on using them on our cold climate. And again, thanks God they're coming and performing the minus, I don't know what is now, minus 35 or something. So they're getting much better also at operating at really low temperatures.
Did you guys put in electric resistance backup toaster elements as a, I guess, a safety measure, or are you comfortable with the equipment will work down to Edmonton's minus 40 degrees and still provide sufficient heating?
So the equipment will continue to work. We are supplementing with duct heaters, purely to avoid wildly oversizing the equipment just to meet that capacity at minus 30 degrees Celsius. And also, since we've got the heat pump water heaters, that load needs to be carried in on that heating load as well, since the heat pump water heater uses the interior air. So rather than oversizing to satisfy all of that, we are going with duct heaters. They're pretty small. I think they're like 500 watts to 1.5 kilowatts is maybe the biggest one off the top of my head.
Cool. Kim mentions that the CFAR program can help with the long-term viability analysis. I think it's a longer, like 40 to 100-year life cycle analysis. Have you guys heard of that one or not as of yet?
No, I've never heard of it.
Okay, it's in the chat. I guess it's for future reference.
Mhm.
Perfect.
Thank you.
I guess there's also a comment about kind of the fixed utility costs. So by cutting off the gas connection, you get rid of that big gas connection fixed utility costs. Did you look at whether or not you wanted one utility connection or multiple utility connections? I guess you've selected the multiple, but does that not maybe increase your fixed utility costs over what it could be otherwise?
Like for the electrical, you mean?
Yeah. The fixed utility.
Yeah,
electrical
we selected multiple, knowing that it would be more, because we want the tenants to pay the bills, rather than
But the bills are zero.
What's that?
But aren't the bills zero?
Well, the bill's not zero though, because there's still, like, they change through the season, right? So there's still going to be electrical bills in the winter when the PV system's not producing that much and the heating needs are more.
So how do you,
also,
not to cut you off, how do you tie in the PV by unit?
Yeah. So right now we're planning, like how I said, we have, I think, 12 of our 16 units that are going to be net zero. I think we're going to tie the system into those 12 units, and then just leave our 6 basement suites like disconnected to the system, and just have them purchase electricity from a green provider. And we haven't worked out the details of how to do that yet. But we're still trying to push to get all the way to net zero so that we could tie each one in. But yeah, that's the intention, is to break the system up and tie it into each unit.
Interesting.
I would say with net zero targets, the biggest challenge that we're facing is just how occupant dense the design is. Like, you're not going to get rid of how many people are using refrigerators and dishwashers and etc. So if you have like a much smaller square footprint for those types of appliances, you just have higher electrical loads associated with those.
So Kelly, if we built the exact same thing, but our lower units were just basements of the upper units, then we'd be able to hit net zero, no problem, right?
Say that one more time. Sorry.
If we built the exact same building,
Yeah.
but instead of having the lower units as their own, apartments, those were just part of the upper units, like a traditional basement, then I think we'd be able to hit, like we'd be at net zero, no problem, right?
Yeah, like don't hold me to it if this ever came up in the future because I haven't calculated it, but I would say yes, because it's just so many additional loads for all those different appliances. So yes, but don't put me on the hook for that in the future.
It's getting recorded.
Yeah, it is recorded, but you can change your mind at a different date. I guess on appliances briefly, what did you pick for clothes washers and dryers?
Oh, I was just doing that. I don't remember off the top of my head. They're all Energy Star appliances, and I'm actually going through the process of like tinkering with them because it actually has a pretty big impact on FIAS modeling. So I can't remember. I'm sorry.
Okay. Did you use like a combination one, or are they two separate appliances?
Two separate, and they're heat pump. Sorry, I was thinking specific brand. So they're like heat pump technology dryers, and they're a separate washer dryer unit.
Except the one unit has a combo where it would only fit in the kitchen.
Oh, I forgot about that.
That's fine. Are you able to keep every unit at 100 amps, or some of the units have to go up to 200 amp service?
I guess we don't have electrical here, so I know.
Todd's not here.
I don't know. I have to answer this
Okay.
question. There's definitely none of the units that are 200 amp. I was just trying to think about. Go ahead, Oscar.
Everything is 100 amp.
Yeah, I was trying to think if there was any that were less than 100, but I can't remember off the top of my head.
I try not to think about electrical if I don't have to, so I don't know.
I guess another question, since it is a fairly dense, I'm assuming kind of your interior loads became a little more dominant and you didn't really have to worry about how much sun was coming through the windows, or how much advantage did the sun coming through windows have on the various units?
So we definitely had to do some trimming down of window areas, and I think we eliminated a couple windows because I was requesting it in the earlier FIAS analysis, just because we're not investing in like giant window overhangs and everything, which I would say you like more typically see on like a single family dwelling, where it's like more specific with like every single detail of each window. Whereas with this multifamily unit, you need to have some windows so that it's like an enjoyable space for the occupant, which is what I heard back from Oscar when I was trying to eliminate windows. But so it's a bit of a challenge to like balance that. So I was seeing some challenges with like hitting my annual heating demand targets with the window areas we have, but not being able to like increase the solar heat gain coefficient because that just was too dramatic, and then that would be no longer hitting my annual cooling demand requirements. But we've gotten to a sweet spot where all our targets are still being met, and I'm just fine tuning the appliances to keep within those targets. I always find it like astonishing to see that like changing the refrigerator can like have such a big impact in my modeling, in my annual cooling demand.
Yeah, I should add right there that is that's probably what we do different here when we're trying to do multifamily. In a house, it's a little bit easier just to control just where you put your windows and what is the size of windows and all that. In this particular one, because we have kind of on the layout on site, different orientations and things like that, it's a little bit harder to achieve, even though if you see it on the design, the north building is even facing the courtyard just to get some of that south sun. We don't want too much. And again, it's the same. Once we have the basement suites, have a different type of energy. So I think that's the critical thing on multifamily. This is kind of different, but imagine another one that could be later on is a multifamily with a double loaded corridor. And those are kind of critical buildings for passive house, because it will be who's the guy on one side that probably get more sun compared with the other guy on the other side of the corridor that doesn't get that much. And if you have centralized system units, it's like comfort for the one on one side or the other side. That gets a little bit more complicated, and that's what not all orientations within the multifamily work kind of for that ideal scenario is what I should say.
Thank you. All right, well, we're starting to come up on 1 o'clock. So I guess any other questions from the audience? And yeah, if not, thank you for that excellent presentation. I love all that data. I think you guys do have some grants, so the data will be going public. Do you have a website, or where will all that data eventually be shared?
We did receive a grant through SRIA, Smart Sustainable Resilient Infrastructure Association, and we will be presenting everything to them, and it will be public through them as well too. Yes.
Perfect. Yeah, great. Thank you all for coming today, and hopefully to see you in January. We won't have don't have a coffee talk in December because, well, 4th week in December is basically Christmas. So we will see you in the 4th week of January. Thank you all.
Yep, I probably should mention, Frank, before that again, with Passive House Alberta, we're also gonna document this thing.
Yes.
And,
yep.
And that's part of the knowledge transfer that we're gonna try to do. What was the experience through all this, and so people can also learn at any time that what happened here and what was that decision made, what can be learned, what can be replicated, and what can be done different, for sure.
Great, thank you all.
Okay.
Thank you.